Okay, so good morning, everyone, um, and good evening. We are excited to start this series of conversation with a Data Science at Home podcast with Francesco, and I will be basically moderating these talks. I don't have like much to say here, but we will be using these sort of conversations to share expertise knowledge around data science in a monthly format with you. And we're excited to start this session from today about the different job roles in data science. And yeah, so we want to start. It would be nice if you introduce you a little bit yourself, Francesco.
Sure thing. Thanks, Nabi, for organizing this. It's really amazing the effort that you've put in this first fireside chat. So I'm Francesco. Some of you, I hope many more than I think, know me from the podcast Data Science at Home that I'm uh, conducting and performing since a bit more than 3 years now. And first of all, thanks everyone for listening and for downloading the episode multiple times. It's always a pleasure. And also the founder of Amethyx Technologies, which is a company that operates in the field of machine learning and artificial intelligence for about 4 years now. And yeah, I'm very excited to put a bit of my, share a bit of my knowledge and experience in the job hunting for data scientists, as I've been a newbie data scientist myself several years ago. So it's always good to share with the new generation, but also the old one, what is how the market has changed and what are the probably some tips and tricks that it would be nice to consider for your first or next mission in the field.
Great, great. Thanks for the introduction. Before jumping into the conversation, I want you all, thank you all for your attendance here and also invite you to follow our podcast page on LinkedIn. We will release Data Science at Home podcast episodes every week. And we're talking about cool topics in data science, machine learning, and AI, mostly state of the art topics. And yeah, so let's start this chat today, this fireside chat. So the initial idea of this chat actually is coming from one of the assignments that I was doing at UBC's Master of Data Science program that we were asked to write a blog post about a recent trend in data science. And the topic that piqued my interest was what are the different job roles in this market, and like as a fresh grad in data science, what are the options that we can take to launch our career in this amazing field? So basically, I did a little bit of research, and without any hassle, I just realized that data engineers are getting paid at the same amount uh, after like having more experience than like maybe 15 years old. So it doesn't matter if they have like 15 or like 20 years experience, their salary won't change a lot based on the stats that we're seeing in the salary reporting website. Uh, what causes that? What is the reason? Like, what affects this sector of industry that like maybe sometimes people are getting outdated or something like that? What do you think? What is your idea here?
Well, there are many ideas. In fact, to be very honest with you, it's not. I'm not. It's not completely unexpected that there is some sort of inflation in the paycheck or in the salary after a few years, and that is something that we have seen applied to different sectors. So it's something that goes definitely across sectors, and also different roles. In particular, the data engineering role, the one you mentioned, in fact, it's not a coincidence that you have seen probably a certain plateau in the graphs after a few years, saturating that curve that doesn't really explode. The more years you have experience, the more you get paid. Uh, as I said, there are several interpretations to this, and I'll try to give mine, which is some sort of inflation of the role that is due to the fact that there are better tools today for doing engineering. And so the data engineer of the past, let's say 10, 15 years, was, required to be a very seasoned individual to manage and to, have ownership of certain tasks in production. And today, I'm not saying that we no longer need engineers. That would be impossible. These people do amazing jobs to give us the services that we use every day. But there are much better tools that automate a lot of those tasks that were kind of critical. I have one simple example that probably a lot of people have used out there, which is GitHub Actions, for example. Uh, the way every time you commit something to your repo, no matter which machine learning model, even without machine learning, in software engineering, there are a series of tests that you can automate almost fully today. And these tools have improved a lot in the years. So as a hiring manager, I try to put myself in the shoes of the hiring manager who has to pay like 100 grants or 150 grants for a data engineer when I can, realistically hire, let's say, a junior role, look for a junior role or a junior position, uh, armed with these much better tools today and get more or less the same outcome.
Hmm.
So now, of course, this doesn't mean that tomorrow we have to go cheap on engineering. Terrible things would happen if we did so. But what I'm trying to say is that on the big numbers, there has been an improvement in the tools that these people use. And without generalization, this applies to the role of the data scientist as well. But probably we're going to discuss that about that in a minute.
Yeah, thanks for elaborating on this because we see how technology is reforming this field and how technology is affecting the jobs and the efficiency of the data engineers. But jumping back a little bit to data science by itself, talking about data scientists, those who are dealing with like lots of statistical models, or like sometimes they're building whatever pipeline. So the thing is, with data science, I've been also receiving this sort of feedback from some blog posts, some trends that I was seeing, that like the amount of stats, the amount of statistical models that they're used in data science, like day-to-day jobs, are kind of getting limited and limited. By stats, I mean classical stats.
Right.
What causes that? Like, do you, first of all, do you reckon this change or this trend, and what is the reason behind this?
Absolutely. So the way we did it, so there is history. Of course, we don't have a lot of time today, but I'll try to squeeze this as much as I can.
Hmm.
Um, Data science, let's say 20 plus years ago, was not called data science, was actually applied statistics. And in fact, data science has inherited, in the first years of existence, many of the statistical tools and solutions and models that come from the classical statistical world. Now, what happened is that we tried in the beginning of data science, the first years of data science, to apply as much as we could what we knew from the statistics world to the new data that were available to us. And at the beginning, it worked pretty decently until it did no longer work, due to several reasons. To the fact that, for example, we wanted to push statistics into a realm for which statistics was not designed for. Let me put it like that. Even though mathematics is mathematics, but big data is also big data. And in big data, many of the statistical tools that classical statistical tools, are no longer usable. Um, I have a very nice example, if you give me a minute, which I experienced myself when I was, in one of my first roles at a very big pharmaceutical company in the past, um, which was, where the job was about analyzing data of patients for a particular disease. Now, don't enter the details,
Hmm.
But essentially, what we had there was using, statistics. There were a lot of folks using statistical tools like, significance and p-values and the confidence intervals, all that stuff that for the students in statistics know what I'm talking about, and that's
Yeah.
like statistics 101, right? It's the first level of statistics. If you don't know these things, you don't know statistics. And
Yeah.
there was the trend to apply these concepts, which are, sound, scientifically sound, of course, but they are designed for cohorts, for example, in which you have usually a few dozen patients or data points. When you move to something else that is a few thousands or sometimes millions of data points, when you work for a big pharmaceutical companies, these numbers are not an exaggeration at all. Well, then you realize that all the statistics that you studied at university is, pretty much useless. Reason for which that cohort analysis, what the statisticians were calling this field, was in fact renamed into real world evidence that is exactly the same, just on much bigger data. And a lot of the
Hmm.
things that were used to see in statistics did not apply anymore.
Hmm. Hmm.
Um, Now, what happened? And back to your question, why? If you repeat your question, because I easily get lost.
Yeah, the question is the amount of classical stats that data scientists are using every day is just getting shrunk and getting
Yes.
limited and limited.
So what happened is that in that evolution, driven by data, in fact, we
Hmm.
had to create, we researchers, practitioners had to create and adopt new tools that were, more powerful and more resilient than statistics, than classical statistics. And so you started seeing more and more the concepts coming from data science, off-the-shelf data science, clustering, k-means, all that stuff. Logistic regression, which comes, it's a pure statistical method, which is not always applicable, and then to the more, heavy
Hmm.
lift numerical methods like, deep learning and
Yeah.
what falls into the realm of more AI and machine learning. So this was a need driven by the data. It was the data driving the tools of the next generation of analytics. And
Hmm.
what happens today is that, of course, we don't ditch statistics. You still have to know statistics, but you have to, take statistics with a grain of salt because, as I said, many of uh, the distributions and the constraints that are valid in a classical statistical framework are no longer valid with big data.
Yeah, yeah, that absolutely makes sense. Um, like it is interesting to see how this field is evolving, and like um, when we see less classical stats being used with like day-to-day data science jobs. On the other hand, we see companies carry more about domain expertise or like data intuition. And basically, what is this balance? Like, what happens here that like companies are like, I've been just like reviewing job postings, like many of them this holidays, and like almost 80% of them, almost like 90% of them, they were like, but we need you having some domain expertise in this field that we're hiring. So what causes that? Like, are the models not working? Or the data scientists, like previous data scientists, were like launching lots of things that they were not like aligning with like reality or like physics of the problem? Or like what causes that?
Well, no, I mean, their intuition, you're raising a very valid point here. Their intuition is, in fact, what makes the difference between uh, a decent data scientist and a rock star, right?
Hmm.
Uh, a data scientist a scientist in general, who has a form of intuition that
Hmm.
doesn't come from the tools that he or she uses, but it comes from experience. It comes from how he or she can merge that gap or fill that gap between, for example, the business and the computing aspects of the business, like the scientists and the nerds, for example. How good that person is at filling that gap.
Hmm.
Also, how good this person is at reading the data. And reading the data doesn't mean throwing the data into a model that you can download from Google or you find from whatever website online. Now you find many and see
Hmm.
what happens. That's not data
Hmm.
intuition. Data intuition is recognizing patterns that your inner instinct as a data scientist is suggesting you. And so you would say, where do I learn these things? Well, in fact, these are, and it's a good thing, these are the things that are not written on any book, in my opinion. These are more the things that a data scientist gains with experience. It's something that comes with the years. Um, I have an analogy here. I'm also a passionate gamer. I find that analogy, I speak about this because I see it for myself. Uh,
Yeah.
when I play a video game, I play for several hours in a week. Um, and what happens there is that there are some patterns that I learn, and when you learn a game, there's no way to transfer that knowledge anywhere else because if you change game, you're actually changing the sector in the equivalent of in data science. It's changing sector. You're
Yeah.
working in fintech, and tomorrow you land into healthcare and pharmaceutical, right? But still, data intuition is something that you bring with yourself.
Yeah.
It's the skill that you can transfer if you have that type of skill, of course. And so if you look at video gamers, the gamers who play a long time or for a long time, they learn this thing. And when there is a puzzle they have to solve in a game they've never seen before, on average, you see that these people can solve that puzzle, much faster and probably much
Mm.
more elegantly than the folks who never played or play much less. So, what I'm trying to say here is that uh, the more time you spend on something, there is the 10,000 hour
Thing.
rule to become a master in something. Well, I'm afraid that data science doesn't is also affected by this universal law.
Yeah, yeah, makes sense. That absolutely makes sense. So we had this to review what we talked about. We talked about some trends in data engineering, and then we switched a little bit to data science. We talked about limited use of classical stats nowadays in a day-to-day data science job, and then we talked about data intuition and also domain expert, which is helping data scientists to narrow down their algorithms for the problem that they're solving. But if we go one step like upper in the terms of organizational structure, we have AIML product managers, those who are basically designing let's say data-based services, the services that they are truly based on the data. Their actual service is the data. They're offering any type of services based on the data. These group of people, these group of product managers, I also have seen this trend that uh, they are somehow complaining about lack of a system for like their workflow management. Apparently, agile system, Kanban system, or like any type of like Scrum model, it's not working for them. Like they're planning for a 3 weeks sprint, and then all of a sudden, at the end of week two, they still need like 2 more weeks. So, what causes that? What is the reason that like the AI ML product management roles are also challenging, and like this challenge has been reported like numerously in the industry? What causes actually that?
Yeah, so I've been criticizing agile. You mentioned agile and agility in general, even in the time it was applied to software engineering. Even though in pure software engineering projects, it makes sense in several sectors to have an agile workflow, rather than a waterfall and whatever you learn in software engineering principles. um, I've been criticizing Agile for data science since the very first days, due to the fact that there are many things that you can inherit from software engineering and mathematics and statistics, and wrap that stuff into the ecosystem of data science, but agile is not one of those things that you should be inheriting. And the reason for that, and also the fact that many projects have failed because managers have enforced an agile methodology, also is not is not impressing me or surprising me in a way. It perfectly makes sense because data science has a lot of moving variables that in software engineering do not exist. In software engineering, you have something that you can measure. You have metrics that are very well defined. The metrics of software quality, for example, the metrics of efficiency, the metrics of time. How long does it take to develop a particular piece of software, a particular feature? Uh, After more than 40 years in software, we know, there is a maturity in that field. And the mistake that many managers have been doing and still do is to apply something that belongs to a completely different world to data science. And that's agile. So when I say agility will not work for data science, is because usually in agile you have these sprints or 2 week sprints in which you have to you narrow down your set of features. You put
Yeah,
your team or a part of your team uh, hammering on that particular feature, and after 2 weeks you want that feature to be to have a
launched.
report of that, and then to report it to the business, and boom, we have a feature. That can work and usually works for software engineering, doesn't work for data science, because in data science you have, for example, data quality. You have missing data. You have data that are connected to the business and you cannot collect for whatever reason. You
Hmm.
have data that are not available because they have low quality. You have statistical drift, which
Hmm.
is a phenomenon in which you see something works today. After 3 days, the phenomenon that you are modeling has changed behavior of people, for example,
Yeah,
or pandemics. It happened overnight. The way people were purchasing things at the supermarket changed during pandemics and immediately after. And we were running the machine learning models that were trained several months before, if not years. Uh, Now, what do? We go back, right? So in an agility
yeah,
system, an agile system, we should simply delete that sprint and start from scratch, which doesn't make sense. So uh, in data science, you cannot apply agility all the time.
yeah,
Um, there are things that you cannot measure exactly, and agile works when you can measure as many things as possible. That's
yeah.
probably the main reason I believe is causing failure in many projects out there.
Yeah, it is really valid. I mean, measuring the KPIs, measuring the progress of a project is one of the main factors of managing it. And once you don't have access to those, let's say, indexes to measure its performance, so model should be changed. And mm, that's not surprising also to see most of the data scientists, let's say real data scientist jobs that like data scientists are doing out there, they are mostly R&D jobs. They need to do a research, like a comprehensive research in the field. They might need to like read bunch of papers about like whatever like kernel calculated in whatever university. So that makes it like challenging. And of course, in project management, we pretty much know that like these are some risks as like assigned to a project, and we should be aware of them. Great. So we are moving to the very last topic of our today's conversation, and then we'll have like a couple of questions asked by audience today, and we'll cover those as well. The very last topic that I was also seeing recently and being trended was basically about data ethics and uh, privacy and ethics managers. First of all, my question is that what do they actually do? What is a day-to-day job of a data ethics manager or like data privacy manager? And also on the other hand, is this just a necessity, or it's something like an um, let's say like a bonus service that some companies are offering? what makes some companies hiring for these roles, and what makes them not hiring for these roles? I think I asked like three questions here. So if
Yeah,
you need to repeat that, let me know in the middle of the conversation.
yeah. Please repeat them later when as I go.
Yeah,
Um,
for sure.
So, so I mean, what is data ethics? Well, we have covered this a number of times in the podcast. So, of course, I invite the listeners to have a better view of what I'm trying to say here, and try to squeeze this as much as I can, for the sake of time, of course. But essentially, data ethics is the way to, there are some principles behind data ethics that um, uh, dictate, or let's say set up a framework to treat data in an ethical way, right? And also to treat the models that are trained with this data in an ethical way. And
Yeah.
so usually the job of a data ethics manager is to enforce, is first of all to be aware of these principles, and
Hmm.
find where exactly in that particular use case, which is very domain specific or even organization specific, uh, find them out in their use case, and then enforce these principles as
Hmm.
much as they.
Hmm.
Now there are, I don't remember by heart, probably I will miss someone. I will miss some of those principles, like the principle of ownership. There is the principle of transparency. There is privacy,
Hmm.
that prevents one manager or data scientist to maintain personal and identifiable information from data,
Yeah.
and so observations that can reconduct to a particular individual, that you can uniquely identify because of that observation.
Hmm.
There is intention, um, and that is the way. Why are you using this data? What are you using this data for?
Hmm.
Uh, and for example, think about healthcare and pharmaceutical companies. They
Yeah.
use, they deal with these principles on a daily basis. When
Yeah.
you train, when you use certain data to train a particular model for, let's say, predict a certain disease, like ischemic stroke, whatever. Now, what happens when the same data can be used to discover or predict diabetes, right? Do you inform the data owners, like the patients, that, hey, look, your data is being used
Hmm.
for multiple reasons here? And now maybe it's quite difficult to find someone who would be against using their data for multiple reasons in case of a disease, for example. But think about social media. Think about all the social platforms. They're not really dealing with health, for which people are willing to pay the price of, let's say, privacy or
Yeah.
intention or violation of intention and all this stuff. Because at the end of the day, they might have a tool that would save their life. But think about
Yeah.
a social network that simply is monetizing your data and is using your data over and over again for multiple intentions, that will empower them more and more, and leave you without any money anyway, right? So
Yeah.
they will not pay you anyway.
No,
Now,
it's
would
true.
you sign for that? Like, that's the thing. Like, if I signed to get my data be analyzed, or get participate in a particular study, uh, I lose control. What happens if I lose control of my data and that data is used again? It's abused, in fact. So that's
Hmm.
where data ethics, plays a very important role. I hope that it's going to be more and more important in the future, because
Hmm.
on a realistic side, I'm a scientist myself, and I've seen these things not applicable many times,
Hmm.
or ignored completely.
Hmm.
And uh, so that's the ideal case. Um, Tell me if I'm not responding to your three
No,
questions.
no, you pretty much got it. And I like what I think here. I think not every company can afford these rules. Is that right?
Oh yeah, like when you look at data science, there are companies operating the data field. They want to monetize as much as they can and as soon as they can. And data science, has been something very very slow for a return on investment with respect to many other uh,
Hmm.
fields out there, right? And so, of course, a company, an organization, has to reassure the investors or their own management that data science is the way to go for their business. And with data ethics, where's the monetization, right? So
Yeah.
it's very difficult to find monetization with data ethics. So this is something that came out in one of the podcasts, which was uh, with Mara Pometti from IBM. Back in we realize data ethics is probably applicable only at big companies,
Yeah.
right? Only those companies can afford, because
Yeah.
it's not something that you monetize the day after. It's something
Hmm.
that reassures the data owners, the patients, the clients, the customers, that their data are being treated ethically, but still doesn't add anything to the revenue stream of that organization.
Yeah. Yeah, yeah, makes sense. This is a valid point that like sometimes data ethics is like standing right against the monetization of the data because like business managers are thinking about crazy ways to like connect some sort of endpoint which is not consented by the user, right? So, um, great. Thanks for this part of the conversation, and the second part of like as always we've got pretty cool and challenging questions. We got two questions. The first question was posted in the LinkedIn chat, and the question is, what is the best role for someone with almost a decade of marketing experience and who now wants to change their career to a data related job? So, you want to share your insight first?
Sure thing. I mean, marketing, spending a lot of time in marketing is very important in a way, because, okay, it's not a scientific, as scientific as the job of the pure data scientist or mathematician who masters the algorithm, or the software developer who masters the algorithm and the methodologies.
Hmm.
But in marketing, you have the chance to look at how people react to, for example, advertisement or to certain
Hmm.
signals out there. So you are closer to the human factor, much closer to the human factor than a data scientist is. So
Hmm.
I think, and I've always believed that studying some, hardcore methodologies coming from the data science world would actually help filling that gap and creating that complementary role or skill set that you have and you would put next to your marketing
Hmm.
capabilities.
Hmm.
So I would go down in first of all, regardless of the sector, I advise always to narrow down and specialize in something. That helps a lot. And try to improve that data intuition mechanism to bring with you when it's time to move to another sector or even to the next mission in the same sector. That's something that nobody will take away from you.
Hmm. Yeah, that's a great point. And from my understanding, as someone who worked in marketing, I think the roles that would be more kind of relevant to data related jobs in marketing are mostly around marketing analytics manager or like marketing insights manager, marketing technology manager. These are the job roles that they usually need you having some sort of 5 or 7 years of domain expertise in marketing and consumer behavior analysis, and knowing the data science tool, knowing how to run an A/B testing, knowing how to do a hypothesis testing, do an inference, or like on the other hand, running a sort of a regression model to see like what are the factors affecting whatever regressor or like predictor. So that's my point also to add to this question. And we've got two more questions as well. It's really exciting. So the next question is that, hello guys, you mentioned that employment in this field gives a big opportunity for a higher salary. So do you think that having a certificate in data science is necessary to embark on such jobs, or experience and your resume can help you in this case? What is your suggestion? So I think here we are comparing having a university degree or like a certificate against having some sort of related um, experience with like data in like not officially naming it data science, but working with data in a field. So I think
Yeah.
this is the comparison here.
So if I were Elon Musk, I would say universities are useless. You can learn anything online, which with which I don't
I'm at the university right now. Look at this. It's
exactly.
here.
So, I mean, I've been spending a
No
big chunk
kidding.
of my life in universities with masters and PhDs and postdoc and whatever after. So I can be biased here,
Mhm.
but that helped me a lot. If I can share my personal experience,
Yeah,
it helped. It was not for the certification per se, like the fact that you come from a university or a particular research institution. Yes, sometimes it can help. It really depends where you're applying, by the way. If you're applying to NASA, probably they want a PhD and probably a PhD from, a Stanford-like university, uh, because that's what, that's the filter they use, or I'm saying NASA, but it can be anywhere else. There are organizations that are married to the certification and to the source where you come from, or the institutions where you applied. I would say that majority, not that they don't care, but they care much less.
hmm
I've seen an evolution in the way people look for candidates. Back in the days, of course, you had the resume that was read by people. Then we had the resume read by algorithms. And
yeah,
now we have, for example, give me your GitHub account and share with me the project that you found the most challenging in your career. And usually it's
hmm
something that you did, for example, the very last thing you did, you shared the repository, and I start reading your code, I start reading your documentation, and I understand a lot of how, what's your way of working from a practical side. Now, this, of course, goes hand in hand with the fact that you know statistics, that you know what an algorithm is, you know how to, you know the theory that is the very basic that you need to master when you get out of these institutions that release a certificate.
yeah.
So my advice is don't get married to the certification, but do the certification because the certification is teaching you something, not just because they are
hmm
releasing paper.
Yeah, that's a great point. Thanks for enlightening that. It was also kind of my question too. I'm right at the middle of an university program in data science, and I was always like wondering whether this like piece of paper will help me or not. Okay, great. And we have another question, very challenging, very interesting. Uh, so this question basically asks, how important is it for data or like machine learning engineers to have a domain expertise today, given the vast array of AutoML tools and readily available state-of-the-art algorithms out there? That's a valid question. The knowledge has been shared and like AutoML tools are like out there. Does it matter if we have domain expertise or not?
Okay, that's a very nice question, and I want to answer this with something I was reading um, a few hours ago, in fact, which is a guy was saying machine learning is dead, long life to AI. Another guy was saying data science is dead, machine learning is in a comatose state, and yet another guy said machine learning is dead, long life, logistic regression. So it really depends where you are.
Yeah.
It's true that AutoML, even deep learning, are kind of changing the way we do data science. Back in the days, we had to do a lot of feature engineering, for example, discovering the features that are representative of a particular data set or can explain that model very well. Today, we have deep learning and AutoML that help you discover these features with automated tools. Now, these tools are not perfect. They will become eventually, in several years, uh, and then we'll write another chapter we will have another fireside chat, probably number 150, when this will happen. um, is it important to have domain expertise? Yes,
Yeah.
it's the number one skill, in fact, that you need, because the job of the data scientist will change, will be replaced. When they say AI will kill many jobs in driving, and as well as in taxi driving, for example, or the cashier, and there is a list of jobs that will disappear overnight. uh, I always have that feeling that data science is also subject to that change and to that
Yeah.
disruption, so to speak. For the simple reason that we data scientists are creating tools that are so good.
Killing our jobs.
Yes, that they will replace ourselves. And it's not a replacement, it's just that we want to focus on something else. If I have a tool that, for example, in healthcare, I have a tool that can detect cancer from an MRI, right? And I have the guarantee that that tool is 99.99% accurate. And then I
Hmm.
have the radiologist or the doctor who has to analyze 10,000 MRIs in his daily job, let's say, or weekly job or monthly job, whatever.
Yeah.
Uh, and of course, if you are unlucky, you will land to a doctor who's distracted, who has family issues, and that day was not really attentive, and probably the accuracy of that particular doctor will drop to 70, 60% if you're lucky. What would
Hmm.
you do if I told you, hey, we have an algorithm that is guaranteed gives you 99.99? Do we kill the doctor and replace with an algorithm? Of course not. But we empower that doctor or a bunch of doctors or the entire category of doctors with powerful tools that support them in their daily job.
Yeah.
Doesn't mean replacing anything, it means enhancing, it means evolution.
Hmm.
Now, the doctor, however, has something that the algorithm doesn't have, which is domain expertise, right? Because that's what you want to use. Let's say you don't use anything of people, you take advantage or benefit. Uh, is the domain expertise of the doctor, is what the doctor has studied, is what the doctor has seen in his entire career, and the human factor of the doctor that is unbeatable. And this is the domain expertise. When you try to move this across sectors, it's
Hmm.
exactly what you need.
Hmm.
If I have at Ametics, we do that all the time. We have several applications when we open a job position, and we have like our way of looking at candidates, potential candidates, and people come with a skill set that several years ago was a dream to have,
Yeah.
but the person who has the domain expertise, even with a bit less, let's say, a less rich skill set, that usually wins.
Yeah. Yeah.
So,
Yeah. That makes sense. That makes sense. I think the main expertise is still dominant in this field because humans are making the very final say and making very final decision about applying these models or not. Great. We don't have any more questions in the chat, and we are right on time. We started at 8:30 PST time, and now it's like 9:15, and I gotta jump into the class like in 15 minutes. So I wanted to thank you, Francesco, for your time today, and basically sharing your insights about the trends in data science roles. We will share the recorded video through our LinkedIn page and our YouTube page. Don't forget to follow Data Science at Home podcast page. And do you have a final wrap up thing, Francesco, before we end up this live stream?
well, no. Well, first of all, I want to thank you for organizing this, and it's been a pleasure to share whatever I could with you guys. And of course, I'm looking forward to the next one. And of course, I keep thanking. It's never enough to thank all the listeners of the show of Data Science at Home podcast. It's a pleasure to have you guys there every week. So yes, and of course, if there are questions, just hit it on Discord or
Yeah.
the official website. You guys know how to reach out to us.
Yeah, for sure. Yeah, thanks for your time. Thank you, everyone, for your today's time on this live. We will meet you on third week of February. So we are gonna have these fireside chats every third week of month. So this is the first episode, and we're gonna have the second episode coming. Oh, we are still discussing about the subject. If there is any subject that piques your interest, let us know, and we will be more than happy to talk about it. And I wanted to thank you for your time, and have a good day, everyone.
Thank you. Bye bye.